Hello students, myself Sachin Srivastav, Assistant Professor in Department of Electrical Engineering from Modi Institute of Technology, Kota. Today I deliver a lecture on the subject of Power System Planning, which is in B.TECH third year 6th and in branch Electrical Engineering. The main contents of my presentation are: first of all, introduction of power system planning, national and regional planning, structure of power system, planning tools, electricity regulation, electrical forecasting, and forecasting techniques modeling. First of all, introduction of power system planning. Basically, planning is the process of selecting vision, values, mission, and objectives and deciding what should be done to attain them. Strategic planning includes long term strategy, medium term strategy, and short term strategy. Basically, long term strategy consists of environmental issues in the power development, interstate issues in the water resource development, land and water availability for thermal power development, fuel quality and transport in thermal power development, functional and commercial issues in integrated operation. In medium term strategy, it includes reduction of the transmission and distribution losses, construction of shorter power plants like gas turbine based combined cycle, cogeneration schemes, etc. And in the short term strategy, improving the performance of existing power plant capacity and maximizing its utilization, and also installing the capacitors at various voltage levels, that is in high transmission and low transmission lines. Next is national and regional planning. The problems in the regional planning relates to the coordination among various utilities in the region with respect to the tariff and backing down of the generating units in the merit order. So HVDC links for the transfer of power between various regions is desirable in order to utilize surplus power in some regions and for stable grid operations. Next is structure of the power system. The amount of power that has to be transmitted through transmission lines is very large, and if this power is transmitted at 11 kV, then the line current and the power loss would be very large. Therefore, this voltage is stepped up to a higher value by using step up transformer located in the substations near the generating stations. Next is planning tools. The planning engineer's primary requirement is to give the power supply to the consumers in a reliable manner at a minimum cost with due flexibility for future expansion. There are three basic techniques used in the planning tools, which are simulation technique, optimization technique, and third one is scenario technique. This is the comparison between different tools: simulation technique, optimization technique, and scenario technique. First of all, in the simulation technique, these simulate the behavior of the system under certain conditions and calculate relevant indices. In the optimization technique, these minimize or maximize an objective function by choosing adequate values for decision variables. And in the scenario technique, electrical utilities should prepare integrated resource plan to develop the best mix of demand and supply options to meet consumer needs. The main examples in simulation technique are the load flow models, short circuit models, transient stability models, etc. in the transmission. In the optimization technique, the main examples are optimum power, least cost expansion planning, generation expansion planning. And in the scenario technique, various types of scenarios for the electrical power are drawn by planning commission, CEA, and state electricity boards, research organization, etc. Next is electricity regulation. The electricity regulation generally concern the price setting, dealing with consumer complaints, monitoring investment in and repair of infrastructure, quality of service standard and monitoring compliance with public service obligations. Next is electrical forecasting. Forecasting of electric load basically consists of long-term forecasting and mid or short-term forecasting. In the long-term forecasting is connected with the load growth and supply, and in the mid or short-term forecasting is connected with seasonal or weather variations in a year, weekly or daily load forecast. Next is forecasting techniques modeling. There are many factors which influence the prediction of the load, and their influence vary from area to area and from country to country, which are time dependent factors, weather dependent factors and random factors. First of all, time dependent factors. In the time dependent factors are regular, irregular or random in nature. The regular pattern is exhibited during the time of day, day of week and week of year and yearly growth. But an irregular pattern is exhibited on the holidays, weekends, special days, etc. Load patterns are different on weekdays and weekends. Second is weather dependent factors. Weather affects the domestic load and public lighting, commercial loads, etc. Principal weather variables found to affect the power consumption include temperature, cloud cover, visibility, precipitation, etc. Last is random factors. There are random phenomena which affect load consumption and can cause large errors in load forecast. These includes school holidays, factory strikes and influence of popular TV programs. Next is mathematical modeling simulation. In modeling, the total load is considered to be the sum of various components due to various factors. These factors need to be measured and interrelated with load requirements. Thus, this technique requires individual modeling of each load type and identifying their interrelationship to arrive at future load requirements. This is the mathematical modeling. Thank you.